Good afternoon, dear colleagues, dear speakers, and everyone who joined in. I like the subject we're going to discuss very much: composite materials and metals. Which materials are going to be of importance and relevance in 10 years, maybe in 20 years, in 30 years, or in 1 year? I think we're going to discuss it with our speakers. Why am I interested in this subject? My background is both in metallurgy, and right now I'm working with composite materials, so both metals and composite materials are very important for me. So right now we are going to discuss with different speakers during our panel discussion what is going on in industries they work, how they see the development of composite materials, which advantages can be gained from using metals, from gaining composite materials. Of course, there are questions with waste management, and there are questions concerning both metals, like slags, and with slabs, with composite materials, we also have waste materials. But I would not make long introductions. I will introduce our speakers, and after that we will discuss it separately with each and every one of them. And please ask questions so that we have a proper discussion rather than presentation of different companies with their own materials. First, Alexander Tunin, CEO of Humatex Rosatom. Welcome. Andrei Laptev, Director of Business Development and Corporate Venture Projects of Severstal. Mikhail Levshits, Chairman of the Board of Directors of the Ural Turbine Producing Plant and Rotec. Alisher Kalanov, Head of Investment Division Rusnana. Alexander Mazhuga, Rector of Mendeleev University of Chemical Technology, and Valery Hurinovich, the General Director of Galen Company. So, if you'd allow, I ask the first question to Alexander Tunin, as one of the major manufacturers of composite fibers and composite materials. We've been working with you for quite a while. We've been covering different projects with you. How do you assess the prospects of the composite materials industry? How did it develop, and how is it going to develop within the few years in the future? What prevents us, our country, from enlarging the production of composite materials? So how do you see this market? Let's listen to your presentation. Thank you for your question, Anatoly. And I would like to make a provocative statement that the era of metal and reinforced concrete is almost over. In 10 or 20 years, the whole world will consist of carbon plastics and carbon fiber. But if we are more serious about that, carbon fiber is much better rather than any other materials like steel. It has much better qualities like yield, like all other criteria. I will not give you quotes about this table, but of course it is very light. It is 5 times lighter rather than steel, and it's very resistant to different corrosions, to different things. So these materials can serve from 50 to 100 years, and they improve characteristics of different products. And of course, we cannot completely replace traditional materials. Of course, we will have to combine usage of traditional materials and composite materials, but it is obvious that the share of composite materials is going to increase. Let's have a look at the major industries where composite materials play a very important role. There are 7 of them: aviation, space industry, infrastructure, first of all, building infrastructure, shipbuilding, nuclear energy, defense, and other industrial applications. If we look at the use of composite materials in aviation, we see that within the last 40 years, the share grew from 1% in such airliners as Boeing, Airbus. They increased the share up to 50%, that is, different fibers, different carbons, and their combinations. It decreased the weight of the plane up to 20%, and it saves fuel, cuts down on wastes and pollution. So it is both money-wise and environment-wise speaking, we save a lot, and it cuts down on costs of exploitation. And the global trends are represented here. And what is the most surprising, none of these trends of the future can keep developing without composite materials. Carbon-free energy production, like wind turbines. The turbines 100% are made of carbon plastics, solar panels, nuclear energy production where they use composite materials in different fields. We have already discussed aviation, environmentally friendly transportation. Everything includes composite materials for the bodies, for the tanks, for medical equipment. So we have polymer base and carbon fiber around them. Then space industry, which is going to increase several times over, and transportation infrastructure, including high-speed trains, shipbuilding industry, and sport industry as well, all those snowboards and hockey clubs. I'm sorry, I've got quite an echo over here. Can we deal with that somehow? As for the development of these industries, the air turbines and space, aviation, sports and cars producing, they are the defining industries, and it's going to grow like 2-3 times in terms of wind turbines. And I'm sorry, there is terrible echo on air. In aviation and space, it's going to increase 2-3 times over. About 21% of materials used are composite materials. Sport industry also is going to increase like 1.5 times. And automobile industry, the technological trends over there, they're going to use hydrogen and gas, and we will have to use special tanks for them. So if we look at the international trends, all the experts see 2 possible scenarios of development. The first one is inertia, preservation of the existing speed of and growth of using of carbon fiber. So we expect over here there will be 100,000 tons of carbon fiber in 2019. It will grow 3 times over by 2030. But as right now all major players try to decrease the costs of carbon fiber by 2020-2030, all the major consumers in car producing industry, in energy industry. Everybody is sure that if we decrease the costs of production of carbon fibers, the usage of it will grow dramatically starting from 2020. There are also black swans in material usage, and the very entrance to the market of a new material by assessment of such experts as McKinsey can be from 5 to 18 years, and it requires a lot of capital. So it means that within the nearest future we will not have any new materials which can compete with polymers and with composite materials on the basis of carbon fibers. So we are not expecting any revolutionary breakthroughs within the next 10 to 20 years. So we are sure that the composite materials will increase their share, but of course they will not completely replace traditional metals. Of course, there will be a combination of usage of both traditional and new materials. The Russian market. There was an important development last year that Rosatom signed the roadmap technology of new materials, and they envisage polymer materials, additive technologies, rare earths, and new construction materials. Within the framework of polymers and composite materials, the roadmap of Rosatom was approved by the government in April 2020, and it envisages comprehensive development of the Russian market in terms of fundamental science like research and development, and then serial production and manufacturing. And it means development both of equipment and development of materials, designing and modeling of ready-made products, making those products, and then making a database of materials, because it's quite a bottleneck right now, because the designers do not have all the necessary information about the materials, how they're going to behave in their products, and they lack experience. So the two very important directions of our work, apart from governmental financing, is, of course, the professional development, teaching personnel, both for manufacturers, producers, and for consumers, and also creating a database of the properties of those materials. On the final slide, I would like to demonstrate the major tasks, the major objectives, and it's not just a strategy that has been approved by the government, and we have this objective together with all the consumers on the basis of our cluster, which was approved by the government. So the key objectives are to increase several times the use of composite materials from 0.8 thousand tons in 2018 to 5.8 thousand tons in 2025. And then Russia should find an important place on the international market. Right now we sell less than 0.1%, but by the year of 2030 we have to increase this share and to be among the top 3 producers. We should be together with Europe, the USA, Japan, and China, and I'm sure that we will be able to do so, and I'm sure that our experts from different companies will be able to share their expertise, and I think they're as optimistic as we are, because we really believe in development of these materials. We believe that's the material of the future.
Thank you, Alexander. I will try to work as in two roles. On the one hand, I will be a moderator. On the other hand, sometimes I will be also acting as speaker because I'm also in charge of introducing, implementing composite materials in aviation, and that's why I partially share Alexander's optimism, even though there are quite a number of bottlenecks that slow down the introduction of composites. I will speak last because I don't want to interfere with the speaker's opinions, but the key phrase that I've heard is that in 2024 you will be dramatically reducing the production costs of carbon fibers. And why I'm saying this is because this is no secret for us that composite structures today are far more expensive than other conventional metal structures. Let's looking at the cost of a kilo of aluminum plate is $8 to $12 US dollars, but the cost of fiber is 5 or 6 times higher, and the material is not all. You have to build a material which will make it even more expensive. This leads to our inability to use composite structures in many sectors of economy that can bring very high added value. What did you say, Alexander, when you spoke about decreasing the production cost? How will it look? Will it be about process? Will it be about energy consumption? There are three main aspects here, three main points, and it's not only about human taxes goals, but also about the global trend. All producers of carbon fiber today work on improving their technology, their production technology, with the goal to reduce the production cost. The second point is recycling, which is the recycling of ready products, of plastic products, because using the technology of recycling helps us dramatically reduce the raw material, and that will be used in end products. All global producers work on that, and we also are making our first successful steps there. And then the scale effect is also there, and working with the first line on carbon fiber production in the country, but being the only one, we cannot achieve the same production cost as the Japanese producer who has dozens of such lines. Therefore, we have to develop, and we have to scale up, and we have to work with recycling. Unfortunately, that's true. Even the global leader offers a more competitive production cost. Then I give the floor to Andrei Laptev, who works for a company that manufactures traditional alloys and who works in the metallurgical industry. How do you see this situation? What is metal for you? How will it be developing? Do you see as the composite materials as the competitor to metals in the near future at all? Yes, thank you, Anatoly. And good afternoon, dear colleagues, dear friends. I'm always very happy to be part of INAPROM sessions. Thank you for inviting me to share my views. I would talk about composites more than metals, because I am responsible for developing new areas, new businesses in Severstal. That's why I take a greater interest in composite materials. I'm still discovering them. I'd like to continue where Anatoly left off. It's about competitive qualities and properties of composite materials. And as you have said, looking at the key consumer sectors and and in our main markets, composite materials are not and will not be systemic competitors to steel or other metals in the near future. If we look at the market of a billion and 200 million tons, and the composite materials market makes up about 5% of this market, and in the main areas, what's important in these main areas is the production cost, and even the highest grade steel, which with the highest end use, will only cost $1.5 per kilo. We calculate tons usually, but with composites we will have to recalculate in kilos, and the mass production will be $0.5 per kilo. And if we compare them directly, then in most segments, composites, even the cheapest ones like fiberglass, are not competitive in terms of production cost. The composite framework will cost many times more than steel, and it also has problems with fire safety and other problems. What makes steel very different from composite materials, and why we look at them very attentively, is the potential and for improvements, improvement of properties, and for decreasing the production cost as well. Steel is an industry which is very mature technology-wise. We have not seen a lot of breakthrough innovations in this industry for a long time, since maybe the 1970s. And this is a very mature and very industry with very hot competition. Most steel producers say they do not make any profit, or only make the profit enough to support their own assets. And composite materials are an industry that continuously works on improving their process and on reducing their production cost. And we see that there are preconditions for reducing the production costs, both on the side of raw materials and on the side of the end product. Looking at our portfolio and why we believe in the potential of composite materials, our venture section has invested was invested by a Netherlands company whose goal is to reduce the production costs of composite materials several times. They work in the high-end segments of manufacturing composite materials for aerospace and other high-performance materials, where, as you know, the scale effect is not working too well. And in order to build these products, we need we need a lot of materials, and a lot of materials are lost during the process. And the company built robot packages, robot complexes that automate the manual work, and that give it to robots. And this reduces the loss of materials, this improves the end products, and improves the amount of the end products. And we see how the costs can go down from $200-300 per kilo to $50 per kilo, and this will happen in the short-term perspective. These things make us look at composite materials very carefully with a lot of interest. Speaking about oil industry, composite plastic pipes take up 1% of the market in Russia, while in a more developed markets, especially in offshore applications, especially where we need adaptive decisions, the share is up to 20-25%. In Saudi Arabia, they have a special program where they build thousands of kilometers of pipelines out of composite pipes. And looking at the technical specifications, they are more efficient than steel pipes. And therefore, to sum up, there will not be a challenge to us within the next 5 to 10 years. There is a very interesting niche that includes oil, gas, and aerospace and high-performance composite materials. And metallurgical companies have very good competences in scaling up and in organizing process and entering markets. And this makes us very attractive partners for projects in composite materials. And we have seen such examples in the West, like ThyssenKrupp, that have their composites areas, their composite departments, and Russian manufacturers will also follow their suit. Thank you very much, Mr. Laptev. I have several short comments. We can look at the Forbes list. If we look at it, I will not agree that that steel producers do not make any money. I haven't seen any composite material producers there, but there are a lot of steel producers in that list. And you said that there is a Netherlands company that does research in composite materials, and I heard that there was investment in this company, and we probably could work better in composites. Maybe we could be competitors to that company from the Netherlands. So it's like that joke. It's not us, but rather you. We have talked with Andrei Laptev about joining efforts and about the investing in that wonderful company. This really shows what we could do, and we have a space for improvement. And we use composite materials actively in our production, and we started doing that in 2013. We were using the most advanced, the most up-to-date machine for their production. I will not be advertising my company here, and then I have one more question. My next question is to Chairman of the Board of Directors of the Ural Turbine Producing Plant, Mikhail Levshets.
So energy building is very, very demanding, and for me, people who work in this industry, they demand respect. I would like to ask you, how do you think you are going to use composite materials in your industry? Or do you think that the traditional materials are going to be mainly used? Good afternoon, dear colleagues. Good afternoon, Anatoly. That was a very interesting discussion. And I'm here not only as the chairman of the board of directors of turbine producing plant. We have several projects, and we do use composite materials in our aviation or alternative energy projects. And right now, solar panels they're made in Russia, and they are installed on a yacht in England. They build small yachts over there much better than we do, but they use our solar panels. But that was an aside. Let's discuss first what composite material is. When we talk about composite materials, we tend to discuss carbon and carbon fibers, but composite materials are much more than that. Somehow it turned out that even in the heading of our session it says metals and composite materials. But right now our discussion tends to go into the direction of either metals or composite materials, and I'm against that because we don't have a panacea. I would like to remind you that the first plane made of composite materials appeared back in 1980s, and the first plane which went into stratosphere appeared in 1986. So the 21st century started using composite materials in all industries, starting from civil building to spaceship building, and the same thing happens with composite materials as it happens with other materials. First, it's the technology of using it, then the experience of running these constructions and using these constructions, and then the experience of their reliability, their toughness. We should have several decades to be able to understand how these materials are going to perform within decades. We should work out methods and we should prepare personnel. We should train people. And there should be generations of engineers and laborers who can work with these materials. As for usage and implementation of these new materials, the most important fields are where they do not enter into a conflict with traditional materials. For example, in wind turbines, nobody thought about using anything apart from composite materials when making blades for wind turbines. So the more new industries we have, the more new generations of engineers we have who are unbiased, the sooner we will have composite materials entering the markets. And of course, the combination of metals and composite materials is going to be used both in aviation industry and car making industry, and details and components will be done differently, and they will combine traditional materials and new materials. It can be said about very traditional industries, like ours, for example. Another thing I wanted to point out is that appearance of these materials, or development, or gathering experience of using these materials changes industries significantly. So, for example, if you came to aviation 15 years back, I used to work with aviation industry and I can describe it to you. Using a plane, making a plane out of aluminium with all those thousands of the components, with all those presses and stamps and everything, that was very expensive, that was very long. And right now we can make a body of a plane, and the technology is almost as simple as making a bathtub out of polymer. And of course the number of companies increased like tenfold, companies which are capable of working with the new materials. And of course it drives the demand for new, for example, turbines. It changes the whole industry. One more thing I would like to say to illustrate this point. If you ask me what is the most material-consuming industry in terms of cement per kilowatt hour, you will be guessing that it's wind turbines manufacturing plants. No, that's solar energy. If you calculate everything, then solar energy consumes most. Then goes solar, that goes wind, then goes nuclear energy. So the more we use composite materials in solar energy, we will change the very essence of solar energy. We will decrease the usage of cement, glass, metal, and we will increase the usage of solar energy on the rooftops of the existing buildings. And that's the direction of our work. We are very active in that, and I hope very soon you will see a very important breakthrough in our work. That's what I wanted to say, and if you have any questions, I will be happy to answer them. Thank you. Dear colleagues, can you hear me now? Great. Unfortunately, here you have some drawbacks of our online conferences as opposed to normal offline conferences where we sit face-to-face or next to each other. Unfortunately, I missed what Alexei said. I wouldn't want to oppose metals to composite materials. I would like to work right now as a speaker rather than moderator. I would like to clarify my point. We do not focus on composite materials per se. It was highlighted in the first part of our discussion, but right now I would like to pass the floor to Alisher Kalanov and talk about wind turbines, and they're using glass fibers rather than carbon fibers. So we discussed that the cost of composite materials is much higher, but why do you use in wind energy production, why do you use composite materials rather than traditional metals? Good afternoon, dear colleagues. First, I would like to thank you for this opportunity to speak to such an audience, and I would like to come back a step about this in this discussion of opposing traditional metals and composite materials. I would like to subdivide it into three blocks. In some cases, the costs cannot compete. Their metals win, of course. The second block is where requirements to the properties are so high that we have to use the composite materials. For example, the blades, like when they more than 60 meters long, and they should be very light. And of course, it can be done only, it can be made only of composite materials. There are carbon fibers and glass fibers and other components which make this material very light. And there is this third block where we can compare metals and composites, and you can use different spare parts and components. That is where we can calculate the life cycle, because it's not the only thing when it is cheap or expensive. In some cases, it's very important to think of the product life cycle, and where the components made of composite material is very reliable, then we can use it. market. And in wind generation of electricity, we have already a plant in Russia which produces blades for turbines, mixing glass fiber and carbon fiber. This is a very long blade, 62 meters long, and we use both types of composite materials. But if we look into the future, the horizon, which is now being discussed by our government, is up until 2035. So the solutions we reached at the first stage may not be all that relevant for the next stages. They may not be used on the market in 10, 15 years. So we will see the increase in sizes of wind turbines, and of course the blades will be larger and larger. And we understand that the new program will be based on 5+ megawatt class, and the blades over there are more than 70 meters long. And of course, the use of glass fiber and carbon fiber will be very different. We will have to use more materials for reinforcement. And if we look at wind generated energy on the whole, there are several trends over there. The first trend is that the wind generation of energy is one of the major things, and solar energy, they become very important in energy generation. They are the future of energy development in our country. And there are two components, offshore component and mainland component. And this offshore component is dynamically developing right now. And from 1-2% right now in the overall portfolio of wind energy production, it's going to increase to 10, 15, or maybe 20%, because we have different products, but in offshore energy production they are larger and larger. Mainland turbines are usually 4 megawatts, but sea-based platforms are up to 8 megawatts. You can buy it from different producers, from different manufacturers, and we understand that in those turbines the ratio of glass fibers and reinforcement, that will be the major technology which would allow us to produce such complicated parts, because they should be very light, very reliable, very robust, and they have to have other characteristics. And that is why they will be produced out of those materials. The long-term trend is increase of usage of carbon fiber. We went through 10 largest vendors, and only one of those vendors, the blade 62 meters long, was reinforced with carbon fiber. The rest did it with glass fiber, reinforced it with glass fiber. And we understand that if the blade is longer than 70 meters, it's impossible to make it without reinforcement, and our vendors understand that. So all of them who are going to be working with 5+ megawatt electric turbines, they will be using reinforcement. They will be using different solutions, different technologies, but all of them will be using reinforcement of the blades. There are two more components for wind turbines which use glass fiber. This, for example, is the casing of gondola and the casing for the turbine. And that influences on the economy. Well, I would say that the blade is the most important thing which influences the overall economy and the overall life of the wind generating turbine. So we understand it that the manufacturer which is going to produce blades, it will entail production all other profiles and elements which are going to be used in creating the wind turbines. I will stop here for a second. We are not talking only about what is happening in our country. We follow the trends in the world, and we see that offshore wind energy production will be combined with hydrogen technologies. So the large European deal, there is this share of hydrogen usage, and there are strategies developed in different countries using this green hydrogen and different other sources of energy, and they have offshore energy producing parks which produce green hydrogen and then use it as fuel. So this is the kind of infrastructure we're going to have, and we will have to use different infrastructure, different transportation logistics, and this is going to be a combination of composite materials because hydrogen, as you know, it has special chemical properties and it makes metals brittle, so you have to have all the tanks and all the pumps and all the pipelines, all transportation infrastructure for hydrogen, which allows for transportation of hydrogen from one geographic location to another. All of that will be using composite materials. And the last point I would like to make, we have these trends and we are comparing the cost of metals and the cost of composite materials, and we say it's going to take us 50 years to transfer from one point to another. I would not be too sure of that. I think that the changes can be much faster. The evolution will be very fast. And many skeptics did not believe in the fast changes we've been witnessing right now. So we'll see how it goes. We see the trends, we see the tendencies, we see how Russia behaves within these trends, and we will be working in further on in the field of our competence.
Thank you very much. I would like to cite the construction of your plant that was happening before my own eyes, as an example for others to follow of how as regards commissioning a plant. On the one hand, this is a wonderful production, but unfortunately, this is not not a Russian production. This is, of course, production by our respectable partners. And in this respect, I would like to ask you, as Ruslan, are we going to build other production facilities rather than that of created by Western partners? Will we ever have Russian localized production rather than localized production? We are actively working on that, and in particular in partnership with the company headed by Alexander, and we have defined the format, and we understand that this is not just a commercial business, but for-profit business, but these are national competences that will not just be viewed and harnessed in the domestic market, but they will also help us create a system of knowledge and values that we will be able to export to international markets. We have capital that has been reserved within this partnership with Imatex company, and we are working actively on that. I want to believe that your work will be successful and that very soon we will see competences that will fully cover the whole cycle from development to production of complete product rather than just wing blades. I would like to add that we have to be consistent. First, we localize what they did in other countries. In Russia, we make products in Russia that are not inferior in quality, and we are in the same. We are competitive. The next question is what value we can add that can be in demand both in the domestic and international markets, and this is what we are building the additional infrastructure for. I wish you great success, and I will be very happy if this happens. My next question, thank you, Alisher. Thank you, Mr. Kalanov. The next speaker is Alexander Mazhuka, the rector of the Mendeleev University, who works in university education. As a composite materials producer, I'd like to say that training of professionals in this sphere is not optimal, and we can discuss many things, but I would like to ask you, as a rector of a university, how will training of professionals change in the near future, and will it change? Will graduates of universities starting to work in our companies be able to understand at least, can they have at least a rough notion of where they're coming and what they will be producing? I will quote an example. I think that one of the reasons that we have not yet discussed, and that is a great barrier to the development of composite materials industries, that the lack of skill by our designers, by our engineers to design composite structures, because designing composite and metal structure is totally different things, and we cannot and we have to be able to use the best qualities of materials and to mitigate the worst qualities of these materials, and we have to train young engineers after they arrive in our companies, because the young engineers just design the so-called black aluminum, meaning that they design the composite structures using the same approaches as they would use to designing metal structures. Will you, and therefore I have a question, will you try and contact us? Will you try and learn what we need? Dear colleagues, Anatoly, thank you very much for your question, and it's very important, and I'd like you to just to tell you that thank you for inviting me. You said correctly that universities have to train professionals, and designing composite materials is more about engineering, but everything starts with us. Everything starts with chemical technology, and chemistry is at the basis of everything. And you mentioned that the profession. This is very right to say that people need to know the properties of materials. You cannot design something in steel and to produce the structure in composite materials. We have been developing this work. We have been working in this direction for a long time, and because everything starts with the polymer, and you need to know how to obtain the right polymer. You need to know how to produce the right monomer with the right properties that will then define the properties of the composite material, of the product made of composite materials. And we work both in producing and recycling composite materials. And what we need to learn as universities is as follows. We work in numerous spheres, in different fibers, and we train professionals in these spheres. We started the program of technologist of composite polymer production. A composite production professional can be of two types. An engineer, which such engineers are trained in the Bauman University, and a chemical engineer, a chemical technology engineer who knows which materials they have to take and in which proportions they need to take them in order to produce composite materials. And we train both bachelor's, master's, and postgrad students. This work cannot be done without the participation of our business partners, and we are very grateful to colleagues from Humantex because we are starting this program together with them. Besides, we are planning to train professionals within the joint research center. It's also important to mention the differences between production and recycling of metals and composite materials. They're both chemical processes, and production of metals is a complex process. But we have not said today that production of metals using classical ways with flotation and hydrometallurgy produces huge amounts of waste in different classes and grades, and there is a huge amount of this waste that has been accumulated by now. And if we go to composite production, then we look at a practically waste-free industry. We use polycondensation, where with the only waste being water, and we need to look at the damage to environment. For now, production of metals is more harmful to the environment than production of composite materials. Then, speaking about making technology cheaper, about thinking about the energy consumption, metal production is in metal production, the consumption of energy is very high, up to 20 gigajoules for production of a ton. Looking at the differences, looking at the trends in polymer production, we started with 100 GJ and now we are at 20. So this shows how greatly the technology has changed in metals. And the same will happen with composite materials. The consumption of energy will still be there, but I would also want to mention waste recycling, waste disposal, and waste management. It's impossible to manage waste without its sorting. Only high-grade steel can be recycled to obtain the source metal. We should of course bear in mind the harm. As for the production of composite materials, this is a new industry. This is the industry of the future. We have started. We know something about polyethylene, polypropylene, and others, but with composite materials, we will be defining the technology in the future. It's good that we do not see a high volume of waste that's from this industry, but this will be a new industry, and we need to define the technology because the technologies that we have now may not be optimal. We need to develop new chemical and biological recycling technologies. We have known metals for 5,000 years, and we have only known composite materials for slightly less than 100 years. But without composites, we would never fly into space, and we would never see achievements in healthcare. And The future lies with composites involving metals. We know that some composite materials are only involve plastics. Some of them are include metals. Will need to focus on new greener composite materials, and the universities also need to promote sustainable development. And in the future, we will need to work on the challenge of disposal of composite materials. Thank you very much, Mr. Mazhuga. And I agree that in metal production, the problem of waste is many times more topical, is more urgent. We at least do not have this water-soluble slag. In composite materials, we have water. We have this water-soluble slag, and our storage fields are not safe. And the production of composite materials will certainly be beneficial for the health of our environment. The cost of harm to the environment is not so high, and that's why the metal production is much lower. And when the costs of mitigating the harm are included into the production costs of metals, first of all, non-ferrous metals, and then the prices will be more or less equal. Composite materials production will become cheaper, and production of metals will become more expensive. And as head of a backbone university, I would like to point out that working with our partners, I understand that composite materials can be very different. There's a very high demand for high temperature composite materials that can be used in high temperature parts of various components, including engines. This is a very important connection, a very important science, a very important cross-cutting science that has to teach us how to produce materials that can withstand temperatures of very high temperatures. Unfortunately, now we do not use that, and this is a topic for a separate conversation.
The general director of Galen company, and we will talk about the industry, which is less known to me in terms of using composite materials. That's civil engineering and building construction, and I would like to state that at the moment use of composite materials is kind of exotic. Maybe I'm mistaken over here. Please tell me the truth. Good afternoon, colleagues. I'm happy to see you all here, and I'm happy to have this opportunity to share my views on the subject. I would like to come back to what Andrei Laptev said, that composite materials are not a threat to use of metals. Metals can be very cost efficient, and there is a lot of legislation, all this paperwork, because we have known these materials for hundreds of years. But if we look onto the very small niche of composite materials, let's say 5% of the materials we are using, like, for example, reinforcement materials we use in our buildings, we see that there is actually a revolution underway. And I would agree with your use of term exotic. Yes, but it depends on different regions. In some regions, the legislation is very proactive towards the use of new technologies, and of course, the number of clients who are going to use these technologies is growing, and they see the expediency of these new technologies. For example, in North America and in Middle East regions, everything which is close to the foundation of the building, everything which is on the ground, basically, it's more efficient, it's more expedient, and sometimes it's more cost-efficient, is with the use of composite materials as reinforcement. And there was a report 5 years ago that 30% of the population are located in the regions of carbonization. And the prognosis for 2050 is about 66 to 88% of urbanization. So people will be living in huge cities. We will receive 2.5 billion of city dwellers, and we have to create an infrastructure for them. And it will be a rhetorical question, of course, that this is a new demand for new technologies. And of course, we will have to build a lot, and we will have to do it very efficiently, and we will have to build it for a long time. So we should not waste so much resources on refurbishment and renovation as we are doing now. And we talk not only about the regions of Asia and Africa, where there is no infrastructure or where it only appears, but we also think of the old world. We talk about the new customers. They talk about different facade solutions and interior solutions, which are impossible without the use of new materials. Yes, the technologies are going to improve, and the costs will be going down, and the situation will be reversed in the metal industry, metal producing industry. But we, as composite materials manufacturers, we should continue working on improvement, the properties and the quality of our final product, because right now we are nowhere near to reaching the properties and qualities which are achieved by metal or by reinforced concrete. Even if they do not use their properties 100%, we still have a potential for further improvement of our parameters, and we should improve the legislation as well. In many regions of the world, they do not have answers to how it should be done. So there should be an educational issue over here. Both designers and architects should understand the properties of composite materials. Right now, they're quite skeptical about them. And a short answer to the question whether we could replace traditional materials with composite ones. Right now, no. Today it will be inexpedient. There are too many issues to be resolved. Of course, it is very interesting, but following a follow-up to what Alisher said, for the past several months we've been experiencing a new reality. Anatoly, I cannot hear you. It will take a minute or so, not more. So right now we are in this period which is absolutely unknown. All the innovations which seemed unnecessary, but today they are quite natural for us. If something like that happens in our industry, yes, I think it may happen in our industry as well. Everything which improves our processes, everything which cuts down costs and makes our work more efficient, everything will become a part of our culture. We should be more cautious about our forecasts, but I think that in about 10 years or so, we will have a completely different ratio of metals to composite materials usage. Thank you for your opinion, and I would like to say that we would be happy to see more composite materials used in our industry, and I would like to summarize. I would like to raise one question about aviation. So right now we started saying either composite materials or metals, but let's look at the aviation industry. Use of composite materials increases the use of titanium, because it's impossible to create a composite construction without titanium fittings, belts, because there are places of workload where composite materials should be reinforced with titaniums, and we cannot replace metals with anything over there. And while titanium used to be very exotic, but right now titanium can be compared with composite materials, or sometimes it's even more efficient than composite materials. So it's a paradoxical thing when implementation of composite materials entailed increased usage of titanium. So we should be saying that composite material is no panacea, no magical wand. It has a very narrow niche where it can be implemented, where they are expedient, but in some areas it won't be replaced with traditional materials. That's all I wanted to say, and thank you very much. Thanks to you all. It was very interesting. Thank you very much, and goodbye. Thank you. Thank you.